2 over n is a constant. Therefore, Sn can be written as 2 over n summation from 1 to n of 1 plus I over n close parenthesis square. Now 1 plus I over n squared is equal to 1 plus I over n times 1 plus I over n, which is 1 times 1, 1 squared. I over n plus I over n, 2I over n, and I over n times I over n, I squared over n squared. Let's write it. Summation from 1 to n, 1 plus 2 I over n plus I squared over n squared. 2 over n, open brackets, summation of 1 from 1 to n plus 2 over n summation of I. We just factor out 2 over n plus 1 over n squared summation of I squared from 1 to n. We factor out 1 over n squared. Now it's 2 over n, and the summation from 1 to n of 1 is equal to 1 times n. 2 over n times 2 over n is 4 over n squared, and the summation of I from 1 to n is n times n plus 1 over 2. 2 over n times 1 over n squared is 2 over n cubed, and the summation of I squared is n times n plus 1 times 2n plus 1 divided by 6. N cancel, we left with 2. N over n squared will be just n, and 4 over 2 is 2. So we left with 2 times n plus 1 over n. 2 and 6, so we left with 3. N over n cubed, we left with n squared. And n plus 1 times 2n plus 1. Now, we're going to do something kind of clever. We're going to take each limit separately to find the limit of S of n as n approaches infinity. So we're going to take each limit using the properties of the limit. We're going to take each limit separately and add them up. It's going to be the limit, then add them up. It's going to be the limit of 2 as n approaches infinity plus the limit of 2n over n as n approaches infinity plus the limit of 2n squared over 3n squared as n approaches infinity. We take the leading terms, and it's 2 plus 2 plus 2/3. It's 14 over 3, and the answer is C. Bye.